To calculate the total number of 480 volts low-bay lighting fixtures that can be put on a 3-phase 20-amp circuit breaker, you need to consider the current draw of each fixture and how the current is distributed in a delta configuration. The question states that each fixture draws approximately 1 amp running load amps and that they will be wired in a delta fashion, with one fixture on phase A to B, one on phase B to C, and one on phase A to C. The first step is to determine the total current draw. Since there are 3 fixtures and each fixture draws 1 amp, the total current draw is 3 amps. Secondly, you need to find the per phase current draw. In a delta connection, the current divides evenly across each phase. The per phase current is equal to the total current divided by 3. In this case, the per phase current is 3 amps divided by 3, which equals 1 amp per phase. Thirdly, determine the total number of fixtures. Each breaker can handle 20 amps. The per phase current is 1 amp. Each phase can therefore handle 20 amps divided by 1 amp, which equals 20 fixtures per phase. Since there are 3 phases, the breaker can handle 3 multiplied by 20, which totals 60 fixtures. Therefore, a total of 60 low-bay lighting fixtures can be placed on the specified 3-phase 20-amp circuit breaker. The key concepts here are understanding the current draw per fixture, the per phase current in a delta connection, and the breaker's ampacity. Always consult local electrical codes and regulations to ensure compliance and safety. This calculation provides a theoretical maximum. Practical considerations such as voltage drop and conductor ampacity must also be taken into account in a real-world installation. For example, the National Electrical Code, or NEC, provides guidelines for conductor sizing based on ampacity and overcurrent protection. It is also important to consider the voltage drop across the circuit. Excessive voltage drop can cause lights to dim or other equipment to malfunction. Voltage drop can be calculated using Ohm's law and depends on the length of the circuit, the conductor size, and the current flowing through the circuit. The NEC provides recommendations for maximum voltage drop in branch circuits and feeders. In addition to voltage drop, you must also consider the ambient temperature when selecting conductors. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides correction factors for conductor ampacity based on ambient temperature. Furthermore, you must consider any dilating factors that may apply. Dilating factors are used to reduce the ampacity of a conductor when multiple conductors are bundled together or when the conductor is installed in a conduit. The NEC provides dilating factors for various installation conditions. For example, NEC Table 310.15. B3. Provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These factors reduce the allowable ampacity of the conductors to prevent overheating. When designing an electrical circuit, it is essential to consider all of these factors to ensure that the circuit is safe and reliable. Overloading a circuit can cause a circuit breaker to trip, which can interrupt power to the lights or other equipment. In extreme cases, overloading a circuit can cause a fire. Therefore, it is essential to carefully calculate the load on each circuit and to select conductors and overcurrent protection devices that are appropriate for the load. Moreover, it is crucial to consider the type of load being served. Lighting loads are generally considered to be continuous loads, which means that they are expected to operate for 3 hours or more at a time. The NEC requires that continuous loads be limited to 80% of the ampacity of the overcurrent protection device. In this case, the 20-amp circuit breaker can only be loaded to 16 amps for continuous loads. This means that the maximum number of 1-amp lighting fixtures that can be connected to the circuit is 16 fixtures. So in this case it would not be 60, but 16 fixtures because of the 80% rule. The 80% rule is a safety factor that is designed to prevent overheating of the circuit breaker and conductors. Overheating can damage the insulation on the conductors, which can lead to a short circuit or fire. By limiting the load to 80% of the ampacity of the overcurrent protection device, the risk of overheating is reduced. In addition to the 80% rule, the NEC also requires that the conductors be sized to carry at least 125% of the continuous load. This requirement is designed to ensure that the conductors are large enough to handle the continuous current without overheating. In this case, the conductors must be sized to carry at least 1.25 amps per fixture. This means that the conductors must be at least number 14 American wire gauge copper conductors, which have an ampacity of 15 amps. When selecting conductors for an electrical circuit, it is important to consider the ambient temperature, the number of conductors in the raceway, and the type of insulation on the conductors. The NEC provides tables that list the ampacity of conductors based on these factors. It is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause lights to dim and other equipment to malfunction. The NEC recommends that the voltage drop in a branch circuit not exceed 3%. The voltage drop can be calculated using Ohm's law. In addition to the NEC requirements, it is also important to follow any local electrical codes and regulations. Local codes may have additional requirements that must be met. It is always a good idea to consult with a qualified electrician to ensure that an electrical installation is safe and code compliant. In summary, calculating the number of lighting fixtures on a three-phase circuit involves several steps. Firstly, determine the total current draw of the fixtures. Secondly, calculate the per-phase current in the delta connection. Thirdly, consider the ampacity of the circuit breaker and the 80% rule for continuous loads. Fourthly, select conductors that are appropriately sized for the load and the installation conditions. Fifthly, calculate the voltage drop in the circuit to ensure that it is within acceptable limits. Sixthly, follow all applicable electrical codes and regulations. By following these steps, a safe and reliable electrical installation can be achieved. Also, remember to consider the ballast or driver type for each fixture, as different types have varying power factors. A low power factor can increase the current draw in the circuit and reduce the number of fixtures that can be safely installed. Power factor is the ratio of real power to apparent power. Real power is the power that is actually used by the load, while apparent power is the product of the voltage and current. A low power factor means that the current is out of phase with the voltage, which increases the apparent power and the current draw in the circuit. To correct a low power factor correction capacitors can be installed. These capacitors compensate for the reactive current and improve the power factor. The NEC requires that power factor correction be provided for certain types of loads such as motors and lighting ballasts. In addition to power factor, it is also important to consider the harmonic content of the current. Harmonics are sinusoidal waveforms that are multiples of the fundamental frequency. Harmonic currents can cause overheating of transformers and conductors, as well as interference with other equipment. To reduce harmonic currents, harmonic filters can be installed. Harmonic filters are designed to block harmonic currents from flowing into the electrical system. The NEC provides guidelines for limiting harmonic currents in electrical systems. Moreover, when installing lighting fixtures, it is important to follow the manufacturer's instructions and to use the proper wiring methods. The NEC provides detailed requirements for wiring methods, including the type of conductors, the size of the conductors, and the installation of the conductors. It is also important to properly ground the lighting fixtures to prevent electric shock. Grounding provides a low impedance path for fault current to flow back to the source, which will cause the circuit breaker to trip and energize the circuit. The NEC requires that all electrical equipment be properly grounded. In addition to grounding, it is also important to provide overcurrent protection for the lighting circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. The NEC requires that overcurrent protection be provided for all electrical circuits. In summary, designing a safe and reliable lighting circuit involves a number of considerations, including the current draw of the fixtures, the type of load, the ampacity of the circuit breaker, the size of the conductors, the voltage drop, the power factor, the harmonic content, the wiring methods, the grounding, and the overcurrent protection. By carefully considering all of these factors and following all applicable electrical codes and regulations, a safe and reliable lighting circuit can be achieved. And remember that while the initial calculations suggested 60 fixtures, the continuous load requirement of the NEC and the 80% rule might significantly reduce this number. Always prioritize safety and adherence to code. The calculations discussed provide a theoretical maximum number of fixtures. In practice, other factors such as voltage drop, conductor ampacity, and local electrical codes may further limit the number of fixtures that can be safely installed. It is always recommended to consult with a qualified electrician to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. For example, the length of the circuit affects the voltage drop. Longer circuits will experience greater voltage drop. To compensate for voltage drop, larger conductors may be required. The NEC provides tables that list the voltage drop for different conductor sizes and lengths. Also, the ambient temperature affects the ampacity of conductors. Higher ambient temperatures will reduce the ampacity of conductors. The NEC provides correction factors for conductor ampacity based on ambient temperature. Furthermore, the number of conductors in a raceway affects the ampacity of the conductors. When multiple conductors are installed in a raceway, the ampacity of each conductor must be derated. The NEC provides derating factors for various installation conditions. Lastly, local electrical codes may have additional requirements that must be met. It is always a good idea to consult with a qualified electrician to ensure that your electrical installation is safe and compliant with all applicable codes and regulations. Remember to factor in the inrush current, which is the instantaneous high input current drawn by an electrical device when it is first turned on. This can be significantly higher than the normal running current. Lighting fixtures, especially those with electronic ballasts or drivers, can have substantial inrush currents. Circuit breakers are designed to handle short-duration inrush currents without tripping. However, if the inrush current is too high or lasts for too long, it can cause the breaker to trip. Therefore, when calculating the number of fixtures that can be installed on a circuit, it is important to consider the inrush current. The inrush current is typically specified by the manufacturer of the lighting fixture. If the inrush current is not known, it can be estimated by multiplying the running current by a factor of 2 to 5 depending on the type of fixture. To account for the inrush current, the circuit breaker should be sized to handle the total inrush current of all the fixtures on the circuit. Alternatively, a slow-blow circuit breaker can be used. Slow-blow circuit breakers are designed to handle short-duration inrush currents without tripping. Also, be sure to use appropriate wiring connectors and terminations that are rated for the voltage and current of the circuit. Improper connections can cause overheating and electrical hazards. The NEC provides detailed requirements for wiring connectors and terminations. Furthermore, inspect the wiring regularly for any signs of damage or deterioration. Damaged wiring can cause short circuits and electrical fires. Replace any damaged wiring immediately. It is also crucial to label all circuit breakers and wiring properly. This will help to prevent accidental disconnection or energization of circuits. The NEC requires that all circuit breakers and wiring be properly labeled. In addition to the technical considerations, it is also important to consider the safety aspects of working with electricity. Always to energize the circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. And never work on electrical equipment when you are tired or distracted. Working with electricity can be dangerous. By following all safety precautions, you can minimize the risk of electrical shock and other injuries. Consider the type of wiring used, such as THHN, THWN, or XHHW, and ensure it is appropriate for the environment, including temperature and moisture levels. Check the insulation rating and ensure it meets or exceeds the requirements for the voltage and application. If the fixtures are located in a damp or wet location, use wiring and connectors that are specifically rated for wet locations. Also, consider the method of installation, such as conduit cable tray or direct burial. The NEC provides detailed requirements for each method of installation. If conduit is used, ensure that it is properly grounded and bonded. Grounding and bonding provide a low impedance path for fault current to flow back to the source, which will cause the circuit breaker to trip and energize the circuit. If cable tray is used, ensure that the cables are properly supported and secured. The NEC provides requirements for cable tray installations. If direct burial is used, ensure that the cables are buried at the proper depth and are protected from physical damage. The NEC provides requirements for direct burial installations. Also, be sure to use the proper size of conduit or cable tray for the number and size of conductors being installed. Overfilling a conduit or cable tray can cause overheating of the conductors. The NEC provides tables that list the maximum number of conductors that can be installed in a given size of conduit or cable tray. In addition to the NEC requirements, it is also important to follow any local electrical codes and regulations. Local codes may have additional requirements that must be met. It is always a good idea to consult with a qualified electrician to ensure that the electrical installation is safe and code compliant. When selecting lighting fixtures, consider the energy efficiency of the fixtures. Energy-efficient fixtures will save money on electricity bills and will reduce the environmental impact of the lighting system. Look for fixtures that are Energy Star rated. Energy Star is a government program that identifies energy-efficient products. Consider the light output of the fixtures. The light output is measured in lumens. Choose fixtures that provide the appropriate amount of light for the application. The Illuminating Engineering Society, or WISE, provides recommendations for light levels for various applications. Consider the color temperature of the light. The color temperature is measured in Kelvin. Choose a color temperature that is appropriate for the application. Warm light with a color temperature of around 2700 Kelvin is typically used in residential applications. Cool light with a color temperature of around 5000 Kelvin is typically used in commercial applications. Also, consider the color rendering index or CRI of the light. The CRI is a measure of how accurately the light renders colors. Choose fixtures with a high CRI for applications where color accuracy is important. Furthermore, consider the lifespan of the fixtures. Choose fixtures with a long lifespan to reduce the need for frequent replacement. The lifespan of a fixture is typically measured in IOs. In addition to the electrical and lighting considerations, it is also important to consider the structural aspects of the installation. Ensure that the building structure is capable of supporting the weight of the lighting fixtures. If necessary, reinforce the structure to provide adequate support. Also, consider the accessibility of the fixtures for maintenance and repair. Ensure that the fixtures can be easily accessed for cleaning, lamp replacement, and other maintenance tasks. It is a good idea to keep a record of all electrical work that is performed. This record should include the date of the work, a description of the work, the materials used, and the name of the person who performed the work. This record will be helpful for future maintenance and troubleshooting. Also, it is important to have the electrical installation inspected by a qualified electrical inspector. The inspector will ensure that the installation is safe and compliant with all applicable codes and regulations.